So still looking at applications of laws of motion. Now let's follow this properly. When you're applying laws of motion, you just need to know the movement of something. Is it moving in the x direction or it is moving in the y direction? That is one thing that is very important. Take for example, you've got this object which is here. It is, let's say it is on a level surface, okay, like that. And then you apply a force in this direction. Now let's say this object is 5 kg. Now your question is, let's say the force which is applied is 20 newtons. The question is, find the acceleration of this object. To be able to find the acceleration of the object, just from the laws of motion, I'm going to say net force. This object is only going in the x direction, as you're able to see. So I'm going to say net force in the x is given by the force going in the forward direction. What force is going in the forward direction? You can see that's the applied force. Do you have any force going in the opposite direction? You don't have. So the net force is just going to be equal to applied force. And from Newton's second law of motion, we know that net force is given by what? Mass times acceleration. And that will be equal to applied force. Mass is 5. We don't know the acceleration. Is going to be equal to applied force, which is what? 20. To find the acceleration, it will be 20 over 5, which is 4 meters per second squared. So this would be the acceleration in this system. Now let's say for this object we are given that there is also a coefficient of kinetic friction. Coefficient of kinetic friction, they've said, is 0.15. Let's say it is like that. You want to find now the acceleration of the system. So in this case, whenever you see coefficient of kinetic friction, then there will be a friction pulling this object, and that is kinetic friction, because it will be moving. For there to give to give you coefficient of kinetic friction, meaning that there is movement. Otherwise, if there's no movement, then you would have been given coefficient of static friction, something that is not moving. So we're going to look at the net force. Now this object is still moving in the x direction, so we're going to say net force in the x direction, that is going to be equal to applied force, force going in the forward direction, minus any force going in the opposite direction, that is kinetic friction. How do you find net force? Net force is given by mass multiplied by acceleration, and that will be equal to applied force minus, how do you find kinetic friction? Kinetic friction is given by coefficient of kinetic friction multiplied by normal force. But for an object that is on a level ground, normal force is equal to weight force. So where there is supposed to be normal force, we're going to put weight force, and we know that weight is given by mass times gravity. So we're going to say acceleration is going to be equal to, we're going to divide everything by the mass, or I can just go direct. Where there is m, we're going to put 5 times a, that will be equal to applied force, which is 20, minus mu k, that is 0.15, the mass, that is 5, and then g is 9.8. So 5a is going to be equal to, let's see what we get. First we're going to multiply 0.15 times 5 times 9.8. So that will give us 7.35, and then divide both sides by 5 here to remain with a. So a is going to be equal to 20 minus 7.35, which will give you 12.65. Then that 12.65, you are going to divide it by 5. So the acceleration is going to be 2.53 meters per second squared. Does that make sense? Paxina, you get that?
Yes.
Okay. So what if you've got an object like this one, and then you have applied a force at this angle? Let's say this is a force of 50 newtons, and then the angle is 30 degrees, and then you've been given a coefficient of kinetic friction as let's say 0.20. You want to find the acceleration in this system. In the same way, the net force is going to be in the x direction. That is going to begin. So this object will not be able to move up and down. It will just be able to move in the x direction. Now, because you have got a coefficient of kinetic friction, meaning that there will be a friction going in the opposite direction. Now, even this force, it has been given at an angle. You need to just get a component that is in the forward direction. So this force is going to be broken into the forward, okay, and also the up. It is going to be broken into x component and y component. This is going to be Fy, this is going to be Fx. So you are going to look at forces in the same direction. So the forward force in this case we are going to use is F. Okay. So use F in the x direction, and then minus what we subtract is the kinetic friction. You know that net force is given by mass multiplied by acceleration. And how do you find the x component of a force? It's given by that same force cos theta. How do you find the kinetic friction? It is given by coefficient of kinetic friction times the normal force. Here I will not write mg. You are going to see the reason. So where there is mass, okay, let's say this is the same 5 kg mass. We are going to put 5 multiplied by acceleration, and that will be equal to force which is applied is 50, and then cos the angle theta, that is 30, minus mu k, that is 0.2, and then just put normal force there. We're going to calculate that. We see what we're going to get. So first I'll work out 50 cos 30. So this is going to be 5a is equal to 50 cos 30. That will be about 43.3 minus 0.20 newtons. Now, times normal force. This is not newton, that's normal force. To be able to find the normal force, we're going to look at the net forces in the y direction. Look at any downward force. So on this object, the downward force we're going to have here is the weight. So we're going to say weight, and weight force is given by mass times gravity. Do you have any other downward force? No. And then remove any upward force. The first upward force we're supposed to have here is the normal force, which is direct up. But also we're going to remove, you have got also Fy. It is also going up. Now, because this object is not moving going up or down, the net force in the y is going to be equal to 0. That is because we know that net force is given by mass times acceleration. There is no acceleration in the y direction because it's not moving in the y. That's why the net force is 0. And that will be equal to mg minus normal force minus, how do you find Fy? It's given by F sin theta. I'm going to get this n, take it the other side, is going to become positive n, and that will be equal to mg. Now m, we know that is 5, g, that is 9.8, and then minus F, we know that is 50, sin theta. Sin theta is 30. So let's see what the normal force is going to give us. So that is 5 multiplied by 9.8 minus 50 sin 30. So that is going to give us normal force to be 24. So you only use the normal force as mg if the force that they have given you is not applied at any angle. That is because in such a case, the only forces in the y direction will be the weight force and also the normal force. So these two terms are the same. But whenever we've got a force applied at an angle, the normal force will not be equal to mg because we've got more than one force in the y direction. And then we'll continue to say 5a is equal to 43.3 minus 0.20. Where there is normal force, now we replace the 24. So that will be 5a being equal to 43.3 minus 0.2 multiplied by 24. That is going to give us 38.5. To remain with 5, divide both sides now by 5. So if you divide both sides by 5, that will give you acceleration to be 7.7 meters per second squared. So this is how you get to work it out in such a case if you've been given. Any question? Any question? Okay. Let's look at another scenario where you can be asked to find the acceleration of a system. So let's say we've got this object. It is connected to a rope, and then there is a second object there. Let's say the first one is 5 kg, the next one is 10 kg. And then you are pulling the second object with a force of 50 newtons. So you want to find one, the acceleration of the system, and then two, you want to find the tension in the rope. Okay, so in this case, there's going to be, because there's a rope that is connecting these two objects, there's going to be a tension in this object. I mean, in that rope. So how do you work it out? So we are going to look at first, let me call this as M2, this as M1. We are going to look at each of these. Firstly, let's look at M1. Let's look at the net force. Because this M1 would be moving on in the x direction, so that will be net force in the x direction. That is going to be equal to forward force, which is 50, minus, do you have any backward force? So here we are taking that this ground is frictionless, there is no friction. So do you have any backward force? This object is going to be more like pulling this object behind, and that is going to be through a tension force. So this tension force is going to be going in the opposite direction. Okay, so that is how it's going to work. Net force is given by mass. Now this is net force in the first one, multiplied by acceleration, that to be equal to 50 minus tension. Now M1, that is 10 times acceleration, that is going to be 50 minus tension. If I take 10 a this side and then the t this side, the t is going to become positive. So that will be 50, and then the 10 is going to become negative. This will be equation 1. And then we look at the second object. So for the second object, also it's moving on in the x direction. So the net force in the x direction is going to be given by, do you have any force going in the forward direction? That force that will be pulling this object, which is here, is going to come from just the tension in this rope. So we're going to say net force in the forward direction is equal to tension. Do you have any force in this direction? No, you don't have any force in the opposite direction. So I'm going to say minus 0, but we don't just show that. So net force given by mass times acceleration is equal to tension. So M2, that is 5 multiplied by acceleration, that will be equal to tension. So here you've got tension is equal to 5a, you've got tension is equal to 50 minus 8a. So equate these two since they are all equal to tension. So that is going to be 50 minus 10a being equal to 5a. Take the 10 the other side, so that will be 50 is equal to, it becomes positive, so that will be 15a. And then from there now divide both sides by 15, so that is going to be 50 divided by 15. The acceleration is going to be equal to 3.3 meters per second squared. Now to find the tension, which is here, we can either use this equation or this equation, or whatever that we want. Let's use the second one. Tension is equal to 5 multiplied by acceleration, and the acceleration is 3.3. So that is going to be 5 multiplied by 3.3, that is going to be 16.5 newtons. This is going to be the tension in the rope. So everything is going to change if there is friction. Okay. So if they've given us that there is a certain friction in this direction, let's say they've given us there is a force of 10 newtons pulling in the opposite direction. So again, we're going to first start working with this one. Net force in the what? In the x is going to be forward force, that is 50, minus the backward force is still the tension here is going to act as a backward force. Forget about this thing, anything there. The only force that is pulling this one behind is just the same force which is here, and that is going to arise due to all the forces that are behind. So that will be tension. Net force still is mass times acceleration, but the mass is 10 multiplied by acceleration, which you don't know, that is going to be equal to 50 minus t. Take t still the other side, so t is going to be equal to 50 minus 10a. So be equation 1. But for the second one, m2, the net force in the x is going to be, the forward force is going to be due to the tension, minus the backward force. You have got a backward force of 10 newtons. Net force, we know that is given by mass times acceleration, but the mass is 5 times acceleration. I'll take this 10, the other side of the equation becomes positive 10, and that is going to be equal to now the tension alone here. This is equation 2. So you can see tension is equal to this and tension is equal to that. So you can equate those two portions. So I'm going to say 50 minus 10a is equal to 5a plus 10. So take like terms to the same side. I'll take the 10 this side. I'll take also this 10 this side. So that will be 50 minus 10. That will be equal to, if the 10 goes the other side, becomes positive 10a, and then plus 5a. 50 minus 10, 40. That will be equal to 10a plus 5a, which is 15a. So divide both sides by 15. So 40 divided by 15. The acceleration is going to be about 2.66 meters per second squared. To find now the tension, you can use one of these equations. Tension is going to be, let's use the first one, 50 minus 10. Where there is a, we are going to put 2.66. So that is 50 minus 2.66 times 10, that will be 26.6. So that is going to be about 23.4 newtons. So this is going to be the tension in this case. It becomes different. Okay. So another thing that we are able to be given. Okay. So in another case, they can give the same scenario like this one. Now let's see the difference that is going to happen. Okay, here we are. So these objects are on a table. They are on a table like that. Now we've been told that in this table there is a coefficient of kinetic friction, let's say of 0.12. We want to find the acceleration and also the tension. And the question is, how are we able to do that? So we're going to look at this mass 1 alone. The net force for mass 1, it is only moving in the x direction. You see, it can't move up or down. It's going to be given by forward force. What's the forward force? That's a 50 newtons. Minus, what are the backward forces? Because of this rope, it will be pulling this object, and that object is going to be offering like a friction. So there is a tension in this object that is going to be causing obstruction. Now remember, the table also has got coefficient of kinetic friction, so meaning that the table is also having what? Friction. So because of the table, there's also going to be friction, and that will be moving in the opposite direction. So these are the two forces which are acting in the opposite direction. Okay. Net force we know is given by mass multiplied by acceleration. That is going to be equal to 50 minus tension minus kinetic friction is given by coefficient of kinetic friction multiplied by normal force. And normal force is times gravity. Now mass, remember we're talking about m1 here. So m1, the mass is 10, divided by the acceleration, that is going to be 50 minus tension minus mu k, that is coefficient of kinetic friction, is 0.12 multiplied by m1, which is 10, multiplied by g, which is 9.8. The thing is, if you get to miss anything here, you are going to get it wrong. So that will be 10a is equal to, what I'm going to do is I will 50 minus this, I'll multiply that. So we're going to say 50 minus 0.12 multiplied by 10 multiplied by 9.8. That is going to give us about 38.24. And then there's a minus tension there. I'll take this tension the other side, and that is going to be equal to 38.24. I'll take the 10 the other side, becomes negative 10a. This is going to be equation 1. And then I'm going to this object which is here, m2. So for m2, also the net force acting on it in the x direction, what force is going to be pulling it in the forward direction? That force is due to the tension also in this rope. Because when I'm pulling using a 50 newtons force, I'm only pulling m1. But because of the with the other one in the rope is going to give it a tension in the forward direction. So net force in this is going to be tension. Do you have any other force in the forward? No. Minus, there will be a friction also because this one is also on the table, and that friction is going to be in the opposite direction like that. Friction is given by coefficient of kinetic friction times normal, which is mu k times mg. Net force index, net force Newton's second law, is times acceleration, and that will be equal to tension minus mu k times mg. So the mass, that is the 5 kg mass, that is 5 multiplied by acceleration, that is going to be equal to tension minus mu k, okay, that is 0. Mass still is 5, g is 9.8. So this will give us a being equal to t minus, we're going to multiply 0.12 times 5 times 9.8, that will be 5.88. And then I'm going to take the 5.88 the other side so that I remain with t. So in this case, t is going to be equal to 5a. The 5.88 is going to become positive. So now we have got two equations, both with a and t. To solve this equation, so since they are both expressed in terms of t, with this side, since they are all equal to 8.24 minus 10a, and that is going to be equal to the other side, we're going to have 5a plus 5.88. So here now arrange like terms. I'm going to 88 the other side. I'll take also the 10 the other side. If the 5.88 goes the other side, it's going to become negative. So that is going to be 38.24 becomes minus 5.88, and that is going to give us a 32.36. If I take the 10 the other side, is going to be plus 5, that will be in a. To remain with the acceleration, divide both sides by 15. So 32.36 divided by 15, that will be about 2.16.
So to find the tension Can use any one of these equations, equation 1 or equation 2. Let's use equation. That is going to give us this 8. This is force is going to be Newton. So this is